So again, we're asked to solve the system of equations by graphing. Our system of inequalities rather, by graphing. Our first inequality is y is greater than or equal to 3x plus 1. So if we graph that, one point is going to be the y-intercept, which is at 0, 1. And then if we go to 2, 3 times 2 is 6, plus 1 is 7. So 1, 2, 3, 4, 5, 6, 7. And if we go to negative 2, negative 6, 3 times negative 2 is negative 6, plus 1 is negative 5, so negative 2, negative 5. It is inclusive. It includes the equal sign, so we graph a solid line through these points. We test a point, in this case 0, 0, but 0, 0 in this case is really close as to whether it's above or below. Because of that, just in case I made a mistake, I'm going to go ahead and choose the point 1, 0. So at 1, 0, we want to know, is 1 greater than or equal to 3x, or excuse me, is 0 greater than or equal to 3 times 1 plus 1, so is 0 greater than or equal to 4. That is false. So we're going to graph on the left-hand side of this line. We're going to shade that region. And now we'll look at our second inequality. Negative 3x plus y is greater than or equal to 4. Now again, you can just plug in your x value and solve for y. Look for the y-intercept by using 0. What I like to do, though, is I like to put it in slope-intercept form. So if we add 3x to both sides, that gives us y is greater than or equal to 3x plus 4. I'm going to go ahead and change the color for the graph. So we have at 0, x equals 0, y is going to be 4. At negative 2, we're going to have 3 times negative 2 is negative 6, plus 4 is negative 2. So negative 2, negative 2. And then at, let's say 2, 3 times 2 is 6, plus 4 is 10. So 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you might already notice something here. Obviously, the lines are parallel. This is inclusive as well, so we're going to draw a solid line through the points. And since these lines have the same slope, again, they're parallel, but we want to test a point. Let's test 0, 0. And in this case, it's definitively below or to the right. So if we test 0, 0, we want to know, is 0 greater than or equal to 3 times 0 plus 4. So 0 greater than or equal to 4. That is false. So we know we shade on the opposite side of 0, 0, so to the left of the line. And what you can see here is that it's the same solution as our first inequality. The difference is that everything that's in between those two parallel lines is not part of the solution to both of them. But everything that's on this left-hand side of our second line, our second inequality, that is a solution to both of them. So there's really no point in shading this a different color, since everything that is a solution for the second inequality is a solution to the first inequality, but not vice versa. But I'll go ahead and shade it in a different color. So everything in this green shaded region now, or everything to the left of our second inequalities line, is a solution to the system of equations. So there are parallel lines that do have a solution, or parallel lines that do have a system of equations that do have a solution. The difference is that if it were on opposite sides, there would be no solution. So if our first inequality were less than or equal to, or if it's in between sometimes, it might have been a strip here. If we had the second inequality, if it was less than or equal to instead of greater than or equal to, then the solution would have ended up being this small strip between the two parallel lines.